Hi, this is Swapnil Bhartiya with Rob Hirschfeld, and this is our limited series on scaling infrastructure as code. And in this episode, we are going to talk about how does GitOps scale infrastructure as code. Rob, how would you define GitOps?
GitOps is a term that's really changing in market. It started off very narrowly defined as a Kubernetes, sort of I want to run Kubernetes descriptions and work inside from Git. But what we found is that the concept of GitOps has really been evocative for people as a way for us to combine immutability and a very clear place to define configuration and state, and then have that automatically handed off into other systems. So we look at GitOps as a way to combine immutability into downstream action. And it's a very good user experience, especially if you have development teams where they're using Git as the sort of source of truth, as the configuration trigger for broader systems. But fundamentally, it's about orchestration. And I think that it's a nice name that implies a lot of developer friendliness for something that we've seen for a long time in the industry, which is service orchestration.
And how does that scale infrastructure as code?
Infrastructure code and GitOps as a concept are really well tied together. And this is where I would bring in things that people assume out of Git that make GitOps very attractive. So when people think about using a Git workflow or development workflow, they assume a concept called immutability. Immutability means that when I'm working with an artifact, I don't change it. If I want to update it, I go through a controlled process, making changes through Git, checking it in, maybe having that merge request approved. I end up with a lot of artifacts that I know exactly what their provenances are, where they came from, how they were built. And that is an important thing to building scalable infrastructures, being able to have part of that process. We found is that those immutable artifacts are really helpful in building infrastructure as code. There's another piece that's very important here, which is version control. And so when I'm dealing with Git, people are very used to the idea of having versioned branches, tags, right? A lot of the things that go into delivering software come naturally and have been built around how we use source code control. And what we've seen, especially at scale, is that it is incredibly important to be able to point to the automation, the configuration that you're using at a site or by a team and know exactly what version it is, to have a language that lets you describe what you're running. And I want to be very specific here because it's helpful. So we have customers that are globally deployed multi-site systems, and they have a dev test prod process where they develop their code and they hand that over to a test team. That test team replicates the environment exactly and then hands that into production, and then production rolls through upgrades site to site to site. And the reason they can do that with infrastructure as code so much more effectively than before is every component of that site has a versioned component in it, or components that are versioned. And so they can literally come back and know exactly what they've deployed to every site. They know exactly what's migrating, and they have a way and a language of describing that. The ability to have that type of control in your site and replicate it in a confident way because of the version control and immutability is transformative. And that's what creates the scaling component in this infrastructure as code. So these infrastructure as code concepts then allow you to scale better.
And when we talk about version control and Git, does that also include build from source?
Build from source is another layer, I think, that people really need to understand how important it is. It is possible to have components where you basically have an artifact and you propagate it around. What we like to see happen in infrastructure as code is to go one level beyond that. It's a very developer concept. So instead of taking artifacts, putting them in a file repo, and then pulling them out of a system, what you really want to be able to do is prove the provenance all the way back from the original source code for your automation for your system. And so build from source actually takes that a level further and says, I'm going to take all of the pieces I need, put them in source code control, and then I'm going to build them out as I need. So for us, that would mean all of the automation components that get built are automatically stacked together, go through a testing process, and then they're compiled from source code and enabled. And that might mean we have a library where you can check things out by version. What we've seen happen with our GitOps practices lately is we're actually able to pull things in from source code control and allow systems to build it themselves inside of the infrastructure platforms. And that actually allows you to have things that are dynamically generated, but still under incredibly rigorous source code control, and also things that are archived and pulled out of archives and then mix and match those. So build from source really extends this concept of GitOps so that you can pick and choose when it's most valuable, and then you can really pull things even into production in a much more confident way because you know where it's coming from. It's a source code controlled object. It's not being sort of hand rolled or hand managed and then injected into a system, which is completely counter to any infrastructure as code practice.
I mean, of course, I'm hearing a lot about automation here, and we also talked about you talked about Git and version control. So also talk about the automation, and does it also means version control, because that's what is happening in the code is moving.
What we look at doing here is really, and this comes back to infrastructure as code's core idea, is we look at building automation as a software product. And that means that you have to have the rigor and discipline, the testing processes, the reusability to do that type of work. In the past, we've always seen automation as something that you built for your infrastructure, or you've built one off, or if it works, great, don't touch it anymore. What we think is much more productive, what we've proven has a much higher ROI, is when you approach the automation you're building in a product way. That means it's made out of reusable components, it has a clear dev process, it has a clear life cycle to it, and it has a degree of portability. So you stop building automation as a one-off process or a throwaway process, and you start looking at it as, okay, if I'm working on automation today, how does it have a 10-year life cycle? How do I build automation so that the pieces that I'm writing today can get reused and be part of my system over the next 10 years or 15 years? It's a totally different mindset in how we look at building automation than how it's been built in the past. And to me, this comes back to why GitOps and orchestration are so important. It's much more about building up a manageable system and understanding all the system parts than sort of just solving a short problem and then pasting things together.
One of the things that people often overlook about Git is immutability. Is that also a factor here?
Yeah, I think that, and this is a mixed challenge. Immutability and, one of my other favorite hard to pronounce I words, idempotency, are really important within how these systems work. But we are talking about building systems and infrastructure at scale. And the challenge that you get into is that people think that they can configure and manage the systems individually or treat them as individual units and then do manual effort. The idea with immutability is that we actually avoid that at all costs. And what we want to be able to do is say, I'm going to produce a system with all the components or with the pieces that I need into it, and then propagate that through my infrastructure. I've heard people say, and I really like this, that infrastructure only moves forward, it never moves backwards. And the immutability concept here means that when I build a new artifact, I'm not trying to fix the artifact I have, I'm replacing what I have in place. And that initially sounds like more work. Ultimately, it produces much safer systems. And Git is like this, right? When people need to understand, right? When you're using a Git control system, you're never actually going backwards in the system. You're really making changes on top of changes, and it keeps accumulating. And the other thing about it is that you can point to those changes and say, this is my body of work. I know exactly what I have. And that's really what we're getting to and how it works. What I would have people do, if you're not used to this concept, is imagine that you have a running infrastructure. Most people's running infrastructure is in a sort of an unknown state, and it might be very hard to recreate what you've built. In an immutable design, you actually could describe exactly how that system got there and what those configuration states are, and look back at the source code control and the source and say, oh, this is what I did to build that site to this state, and repeat it and rerun it. That's what we're talking about with immutability. And the closer you get to having a completely machine-defined infrastructure, that is really getting you closer to infrastructure as code. And I think when a lot of people think about infrastructure as code, that's what they're thinking. It's a machine-defined infrastructure. They just sometimes forget that the purpose behind using Git around that isn't just the definition piece, it's actually the people piece. The Git is about the collaboration software. It's not actually about defining all the bits and bytes.
Can you also talk about what kind of impact it has on day-to-day operations?
Oh, I'm glad you brought that up. Because I was just talking about collaboration. Day two and collaboration are very tightly linked because, right, when you're collaborating with people, that's where things start to change. We're seeing a ton of excitement around day two in systems and the infrastructure here. And what that means is it's not just can I set up the systems, configure them, and get them online, but how do I maintain them and manage them and change them? In a cloud native world, we're talking about much more dynamic clusters and infrastructure where we might completely destroy parts of our infrastructure, recreate it, bring it back online, resize clusters, bring up new systems, monitor the price and change it, change systems based on cost control measures or security vulnerabilities that we have to roll out. And this is where I think we need to rethink of GitOps and other components like this as orchestration, right? It's not just can I run Terraform or can I run Ansible, but can I orchestrate the behavior of those tools in sequence and respond to an event, a webhook coming in from a service ticket system? Can I generate a ticket and send it someplace else? I think that when we look at infrastructure as code, the evolution is very clear that we need to see it as a very dynamic system where it's responding to other systems. That's where the orchestration comes in real time, and build that as part of our system. It's not sufficient anymore to run a Terraform plan and walk away. We have to have a process by which we are constantly reviewing, updating, and changing the system dynamically as code.